Hi, and good afternoon. I'm Aaron Pressman, a tech reporter at the Boston Globe, which is located not far from here, just across the Fort Point Channel. Here in the Boston area and at the Globe, we've been following quantum computing for decades. Boston, with its great academic institutions, as you may know, has been an area that has done a lot of work in quantum computing. And we've generally thought about applications that you've heard about all day today: optimization problems, cryptography problems, simulations. But just about 2 years ago, at the end of 2022, we had a new application suddenly pop onto the scene: ChatGPT, generative artificial intelligence. That research had been going on for a while before, but now it's on the public conscious, it's on corporate America's conscious. Lots of people are wondering how it can work for them. And it turns out there's actually a connection, a deep connection, between how generative AI works and what's going on in quantum computing. That's what our guests here today from Zapata AI, which came out of one of our academic institutions here in Boston, the one in Cambridge. Their work is at the interplay between generative AI and quantum computing. So I have here with me today, right on my left here, is Chief Technology Officer and co-founder of Zapata AI, Yudong Cao. And then next to him is Chief Revenue Officer, Jon Zorio. Do you guys want to give a little intro?
Yeah, great to be here. Thanks for the introduction. My background is in computer science, and anecdotally, so I was a mechanical engineer by training, and how I started becoming interested in quantum computing was actually because I learned about D-Wave, and that was quite a few years ago. So I had to say that D-Wave is a lot less controversial than when I first looked into quantum computing. So this is one, true bookmark, true hallmark of progress. So I've spent over 10 years doing research in different areas of quantum computing, especially how quantum mechanics can be used for accelerating chemical simulation, optimization, machine learning, among others. And the journey so far at Zapata has been incredible in terms of seeing not only the science, but also the engineering and some of the commercial activities unfold. So yeah, great to be here and happy to share what we've learned. Pass over to Jon.
Thanks, Yudong. So very briefly, and I made my brief cameo this morning for what it was worth. Jon Zorio, I'm our Chief Revenue Officer, Chief Business Officer, Chief Growth Officer, as Rachel likes to say. Have been working with clients in a consultative fashion, selling and delivering machine learning and AI solutions for a better part of 7 or 8 years now, and have sort of seen this field grow from what was theory and things that were off in the distance, becoming real core to the business operation to drive real revenue, real operational efficiencies, and so on. And so when I was introduced to Christopher and Yudong and the team last summer, I was too irresistible to refuse to join the team. So thrilled to be here.
Yudong, Jon this morning mentioned about how there is a deep connection between quantum and generative AI. Tell us a little about how quantum computing can enhance how generative AI works.
Yeah, so we've been following very closely the thread on quantum supremacy pretty much since we started the company. So I guess in general, I should say that we've been following very closely the thread on what's the fundamental distinction between what can be done quantumly in terms of computation versus what's possible on a classical computer. Part of that is that the distinction is very much about the unique statistical power of quantum devices. And this applies not only to quantum annealers, as D-Wave demonstrated recently, but also gate model devices and other controllable quantum systems. So this is a threat that we focus very closely. And we've been, pretty much since when we started the company, we've been looking at generative modeling as a use case for quantum computing. And at that time, I think it was 4 years ago, when we first started looking into how to use the small-scale quantum device combined with classical AI to solve real-world problems. That was still a rather tentative use case because generative modeling is still relatively obscure. I think for the longest time, the popular use cases in AI are almost all supervised learning, image detection, object classification, in the computer vision. And generative modeling is rather sort of obscure area where it's very difficult to define, for instance, the objective function. Until 2 years ago, when suddenly generative AI becomes the headline, and it doesn't take a long scientific discussion to really explain what does it mean for AI to generate novel and interesting samples. So for us, the connection between AI and quantum is very much about how we can leverage the unique properties of quantum mechanics, the statistical, the underlying unique mathematical structure and the statistical structure to bootstrap AI in ways that would not be possible with conventional classical computers.
So another way to say that is you guys were working on generative AI before it was cool.
Indeed.
100% correct.
Yeah.
Jon, tell me a little from a commercial perspective, what types of problems, what industries are you looking at for this quantum Gen AI combo?
I think the characteristics are things where there are infinite number of permutations, very heavily data-centric complex workloads where, if historically or to this point, large companies have been throwing tens of millions of dollars at these problems to train and retrain models and build, in some cases, custom maps, but the investment is massive and growing. I think we're having a lot of conversations on mission critical type use cases where whether it's a telco looking to monitor their network, there's defense entities looking for situation awareness or decision support in those spaces. More recently, drug discovery is becoming a new place where we're unlocking the possibilities of these tools that we can put to use where it might have taken many, many years to discover a molecule that could become commercial and solve cancer in some cases. We can now compress that timeline down into something much more, it's not immediate, of course, but we're having that time that it took and that investment that it took. And drawing down the compute resource required, the energy required. So it runs the gamut in that respect.
Yudong, what's a concrete example that you would give of how this might manifest in the real world?
I think there's still a lot of open research questions that we need to address to truly hone in on a concrete example of quantum applied to AI with concrete demonstration of advantage. But I would say that the intuition is that there are, for instance, problems that are inherently quantum mechanical, and the problems that Jon mentioned, drug discovery, problems related to design materials, design molecules. These are problems where the search space is very large, and the data set itself is driven by some underlying quantum mechanical behavior. So there's some atomic and molecular processes that is driving the fundamental behavior, driving the fundamental phenomenon that one is trying to observe. So these are the data sets where we believe that devices with quantum properties, quantum computers, will be able to play a big role. So I would say it's still early days to name a concrete use case, but we have some intuitions on where to look.
Thank you. Jon, in the larger tech world, quantum and generative AI are generally thought of as separate categories. I know they're working together in parallel in your case, but are you worried at all concerned at all about some competition for investment dollars or attention on these two separate areas?
Candidly, no, I'm not worried. I think there's a lot of education, maybe to Yudong's point, that we still need to do, and we're having those types of conversations with our clients where we'll engage and we don't come in with a predetermined answer. We sort of consult our way through the problem, ask a lot of questions, do a lot of discovery. And if we come to a conclusion that given the nature of the use case, the complexity, the workload, the d-dimensional space, as Yudong mentioned, or there's any number of permutations, maybe the quantum-inspired, quantum-enhanced techniques make more sense for that particular use case. But we don't lock ourselves into one or the other. We sort of let the customer, we kind of go down the path together in terms of discovery to figure out what size, shape of solution makes the most sense based on that customer's readiness. So I think that's still, I don't think there's one predetermined answer. So I don't see there being competition per se. It's, I think, what suits the problem or what suits the challenge in that given instance.
Understood. Yudong, you were saying in your answer about the concrete examples that maybe we're not quite there yet. What are some of the technical hurdles that you're facing in this combined area?
Yeah, that's a great question. I would highlight two main types of hurdles. One is the scientific hurdle, which is that now we're in the era of AI where there's an explosion of ideas. So LLM was 2022, 2023, that was the rage. And this year we've moved on to multimodal learning. And then transformer was, in the past 5 years, it was a very popular model, but this year we've seen new architectures like Mamba and other selected state space models coming up. So this is an exploding field with all kinds of ideas about the model architecture, about setting up benchmark, about different varieties of ways in which you can mix and match these building blocks. And pretty much every week there's a new AI paper coming out with a different permutation of different building blocks on a specific data set. So this is the state of play for AI, and the hurdle here for quantum is to see what is the best place in the world of that AI discourse, right? Where is the best place to position quantum? And so I think the talks today all sort of gesture towards different ways in which quantum can be incorporated. I think this is still a very rich research topic just by itself, from a scientific point of view. And then the other side is sort of complementary to the scientific hurdle is the engineering hurdle. So being able to, for instance, compare 10 different model architectures on 10 different data sets, that's 10 by 10, that's 100 different experiments to run. So how to orchestrate the workflow, how to track the experiment, how to register the models, and how to build the whole pipeline from training to inference. So there's a tremendous amount of compute and software engineering problems, and that sort of cuts across ML and quantum. So these two hurdles, I think they go hand in hand with each other, and it requires a very deep collaboration between experts in the domain and experts in machine learning and experts in quantum to come together to address those.
Just to add to that, I think when we start to then merge that with the commercial aspects, we've been sort of our thread today, there start to be some practical constraints you go inside a Fortune 500 company, there's only so much budget for innovation, there's only so much budget for operating expense. As we start to get in deeper in these conversations, where Yudong was going, you're not comparing, contrasting them, but it's a business case, becomes kind of the old-fashioned way of doing an investment analysis on a piece of technology. If quantum can help us deliver more performant models faster with far less compute, that's going to win the day every time relative to some other techniques. And so we're just starting to see that type of analysis being done. We're starting to lead those conversations, but that's, I think, where the world is going. It's the line can't just be up and to the right. I think the journal or someone or one of your competitors had said the AI is eating the world. It's going to be 3.5% of global GDP by 2030 and bigger, and it's a massive $1 trillion problem. It's not sustainable. So we have to find ways to be more efficient with better outcomes.
I did write a story last year. There are estimates of the GDP impact of generative AI up to $6 trillion now.
There we go.
So I think that might be a hype measure, but we'll see.
Right.
I do want to pull at that thread a little more, Yudong, maybe. Everything isn't going to be Zapata AI. How are you working in collaboration? How do you see that with either academia or governments or other companies?
Yeah, and we are very focused on the software and algorithm aspect of how quantum and AI can make an impact. So we definitely benefit from partnering with hardware providers like D-Wave and also other quantum hardware providers, as well as companies like NVIDIA and also other classical specialty chip producers that can advance on specific niche areas. So partnering across the stack definitely is beneficial, because that's the way to cut through the complexity and really get to the use case, which is to embrace this sort of leaky abstraction where the algorithm people need to work very closely with the hardware people to line up the stack toward this one goal. And also we benefit from partnering with universities. So Boston is one of the most intellectually nurturing places in the world with many top quality universities, and we certainly benefit from being very close physically and as well as collaboratively with MIT and Harvard, among other institutions. We run an intern program very successfully in the past few years, and those have constantly been pleasant surprises. And we want to continue essentially providing opportunities for these talents in the field as well.
Jon, I want to follow up with that because in addition to these academic places, we also have a big growing business ecosystem. Zapata is not the only one. How do you see the Boston area for quantum?
Well, I mean, incredible source of talent, obviously. I think the Boston ecosystem has always been out front in these types of, let's say, technological advancements. I think, frankly, and not to self-promote here, but I think we're a little bit unique in that given, all of our founders, with maybe the exception of Professor, are still with the company. So it's not that the team is scattered. We still have all the co-founders with us, still very much believe in the mission. And that's been an amazing team sort of environment to walk into. I'm relatively a newbie, but to come into this environment where it's, there's such intellectual rigor and there's the scientific solutions part of our business is still very robust. It's just as it is on the commercial side. And I think that makes us very unique, that we're doing a lot of cutting edge research and that can help feed insights to the commercial side. And then we can take those to our customer and partners. And as Yudong mentioned, our university relationships, but then that crossover with the work we did at InSilico and University of Toronto to go find more viable drug cancer candidates in a record time. That's an amazing collaboration of business, university, and then our thought leadership as well.
I'm curious, another thing that's a little bit unique about you guys is in quantum, we don't necessarily worry so much about some of the ethical and bias issues that we worry about when artificial intelligence comes up. Yudong, are there ethical considerations in the kinds of generative AI projects you're looking at as well?
I think at the moment we don't have projects that directly target ethical issues, but there are, for instance, with quantum, a persistent threat of cybersecurity, and we've been also following and contributing to that conversation over the past few years, which is the question that I think the world wants to know is what's the threshold beyond which we will have a scalable quantum device that's large enough to, say, compromise most of internet's encryption. It will be a watershed moment for the world, and it's an extremely important question. So I think there's definitely an ethical component to this, and we've been looking very closely at perhaps the scientific aspect of it. What are, other than Shor's algorithm, right? What are alternative ways that an adversary might try to attempt this kind of crypto attack? So that's a scientific question, but also I think it has a strong sort of ethical commitment behind it. And then for generative AI, I think we're still at the early stage in terms of model alignment, in terms of making sure that we can avoid hallucination. I think it's still open to see how quantum can contribute to it. It's a very rich research topic.
Jon, do you hear any of those kind of concerns from customers as you're out there?
We do. I think when we engage, at least on the generative AI side, more often, at least in the last 6 to 12 months, you're starting to see more prompt attacks, other things happening to LLMs. One of the first questions, depending on who we're talking to and whether it's a regulated industry, tell us a little bit about how you go about building models and how would you work with us? Would it be our data, or do you want to own elements of our data? The answer is always no. It's your data. We want to build models purpose-built for your business problem, and you own your data. We don't want to own it. So it can remain very secure. The governance aspects, the compliance aspects are top of mind for us when we engage. And again, depends on the level of sensitivity across industries, but we want to build that security and governance into how we operate.
Got it. We're almost out of time, but Yudong, I wanted to ask you, what in the larger field of quantum computing, what are you most excited about coming around the corner? What do you think is going to be the next big thing?
Yeah, I'm very excited about how the field can come together and better define yardsticks that everybody agrees on when it comes to measuring progress. So in the past few years with the Zapata team, we've looked very closely at different use cases of quantum computing. We've also worked with a lot of different hardware providers, and a lot of times the the challenge of determining progress is that everybody has their own yardstick to measure progress, and a lot of times to make an apples-to-apples comparison, the field needs to come together and reach some level of consensus. And then through the DARPA quantum benchmarking program, which Zapata participates very heavily, we're starting to see some of that, some of the results that gesture towards that consensus, at least in terms of application North Star. And the hope is that that North Star can be used to also foster some kind of collaboration all the way across the stack, all the way to the hardware level as well.
John, just if 30 seconds, you want to add anything there?
Oof. What am I excited about? I think when we start to build more proof points, more customer success stories, and again, not to put my squarely commercial hat on, but we've been embarking on these proofs of concept, which is always going to be the case in this space. We're starting coming to the end of some of those where they graduate into production applications, or we can start to talk about the results, and to be cautious about that as a public company, but those results will be coming soon. Very compelling results that we can start to say, hey, there is a there. There's real value versus the old way and the way we're leveraging quantum-inspired techniques to radically transform how some operations, some executives are thinking about their business. We're just getting started, and we're super excited.
Sounds good. I'll certainly be watching at the Globe, and I hope all of you in the audience will be too. Let's give a hand to our panel. Thank you.